People online, are you able to hear me? People online, are you able to hear me?
Yes, sir.
Okay, thank you.
Yes, sir.
So I was playing some music here. No, that's mine. Yeah, thank you. Thank you. Yeah. It is. So I'm sorry about the delayed start once again. Our chai was not ready. I don't know if you had chai on time wherever you are. And the music, I tried to play music, so this was just a random what I asked Professor Google to find Hindi music related to travel. This is the playlist that they gave. Any questions, comments before I move to the next part? I have about 25 slides that I need to discuss with you. This is a continuation of what we did. Questions? Comments? Okay, I have a question for all of you. Specifically, this was to address the feedback I had is please show us how to merge the data sets. Was that clear enough to figure out at least basically how to merge the data sets? I see some nodding heads in the room, but I cannot see any of you online, so please respond audibly. No, okay. So to build on what we discussed earlier today, I want to pick up on how to estimate what might be crashes or safety improvements that we could derive from different interventions. So that's where we came about with the crash reduction factors or safety performance functions. Now how do we model it? Over the last 3 days we have looked at many variables that relate to safety outcomes. Many of the times what we have looked at is it is correlations of factors. So far we have not looked at straight causality. Is a certain input causing a change? In order to prove that, we have to use statistical methods to say yes, this is either positively or negatively affecting the outcomes. As I mentioned earlier, I am not going to go into deep mathematical formulations. The next 7 or 8 slides I will quickly go over different mathematical approaches. I know most of you are in the MTech, MS or PhD programs, or a few of you are working. There may be a few of you who are undergraduate students. It's for the postgraduate students and PhD students. If you're not already doing it, it is something for you to consider if safety is an area. For undergraduate students, it's something for you to be aware of as how might we model, we come up with tools to estimate outcomes. And the outcomes, once again, I want to make sure you understand there are multiple ways to characterize outcomes. One is the frequency or counts, total number of crashes. The first example I used this morning, 1000 crashes versus 1020 crashes, 1000 outcomes, injuries, fatalities, 1020. The next is break it down by severity. So many fatal, so many A-types, so many. So, but these are still counts. Professor Maurya also showed earlier today how do you look at that, how do you do a heat map, how do you do the black spot analysis where you have a concentration. But by looking at counts, we are not accounting for exposure. We have to look at vehicle kilometers of travel or vehicle miles of travel, and I gave you examples of the same too. 10 crashes versus 20 crashes or 10 fatalities versus 20 fatalities. You cannot compare it that way. It may be 10 fatalities per 1 million vehicle kilometers, 20 fatalities per 10 million vehicle kilometers. So look at the rate. Yet other ways, I showed you these in charts over the last 2 days, is proportions, fraction. What fraction of the total crashes in this area are fatal or fatal and A-type? How about in another area? So now we are looking at percentages. The reason I bring these up are some are discrete variables such as counts 1, 2, 3, or you may say less than 10, 11 to 20, so on. Others may be continuous variables when we look at rates. X crashes or X fatalities per vehicle miles of travel or per population per registered vehicle. When you look at fractions or proportions, that is different. So, the types of statistical analysis we do will be dependent upon the type of variables we have, whether it is the dependent variable, that is on the left hand side, y equal to a1x plus b1x, so on, or if we could have a combination, some variables that we use on the right hand side of the equation could be discrete, others could be continuous. How do you mix and match that? Some may have values that range from 0 to million, others may have values that range from 0 to 10, and if you use both of them in the same model, it may not give you the appropriate levels of significance. So, how do we normalize that? Sometimes what we do is we normalize it saying this is 100, and if it is above average you will have 101, 102, 110, 200, so on. If it is below average, it is. So, now everything you can use on a scale of, let us say, 50 to 200 or 100, 0 to 200. You are not having a scale where you have on the one hand variables have values of a million, on the other hand you have variables that have values of 100. Is there anybody who did not understand these comments? Online? Okay. So, keep these in mind. So, what models are appropriate, what statistical tests are appropriate, and we often assume that data are normally distributed. That is not necessarily the case. When they are normally distributed, we use parametric analysis. When they are not normally distributed or we cannot prove that they are normally distributed, you have to use what are called non-parametric approaches. So, here what I have shown is one way to look at the dependent variable is the expected number of crashes as a function of traffic volume, roadway characteristics, so on. And the example I have here, the first one here on highway segments, the number of crashes is AADT or ADT, which is a traffic volume raised to some exponent times e raised to b01 beta 0 beta 1 x1 beta 2 x2, so on. So, now the x1 x2 are other variables, such as it could be the number of registered vehicles, number of people living there, number of vehicle kilometers of travel. It could be number of policemen per 100 miles of roadway, 100 center line. As long as there is a reasonable causality, it may come out that in your modeling it says this variable is not significant. I do not know if it was Dr. Bhardwaj or Professor Maurya had shown some modeling examples where it showed some variables were very significant. There were other variables that had p values of 0.56 and so on. I think it was you, right, Doctor? Yeah. So, pay attention to that. The second one is intersections. Now, what you see here are the volume on the major street times the volume on the minor streets times another set of variables. For intersections, what is interesting is how many cross trajectories are there. That is why you are using the volumes of major and volumes of minor street. Here are two models or two charts that show. The first one on the left is for safety performance functions for multi-vehicle on rural 4-lane highways. So, this is multi-vehicle, this is single vehicle, I highlighted it in red. So, note that these are very different. So, now you have the predicted crash frequency versus traffic volumes. You see this one is exponential curving up where you have multi vehicles, whereas on single vehicle it is curving the other way. These are based upon actual observed data. This morning I think it was Ritvik who asked, how do you come up with this SPF? It is based upon many dozens or hundreds of observations, and here is an illustration of all the observations. Now, these are things I touched upon earlier in the last 2 days. Other than what is reactive, when we look at crashes and so on, we are responding to what has happened. How might we look at the other things on the pyramid? Remember the safety, there are trillions of safe passages, there are billions of passages where you have some evasive maneuver. So near miss is heartbreaking. So we can look at it as somebody sitting on the roadside or at an elevated spot making a record of that. But with today's technology, we can use cameras to detect that and computer vision to decipher what is it. But more importantly, or more increasingly, what we are using are mobile phones and capturing that, or other forms of sensors that are either built into the vehicle by the original equipment manufacturer or add-ons. Particularly in corporate fleets, such as maybe a company has many Uber vehicles or taxis, a company has many delivery vans, Amazon or whoever it is, or it may be a trucking company who have hundreds of vehicles on. They can instrument their vehicles with other sensors too. So getting data today is a lot easier than even 10 years ago. 10 years ago was a lot easier than 20 years ago. 20 years ago was a lot easier than before. So it's eases the quantity of data per cost is going up exponentially that we can get. Now how do you derive meaningful inferences from this? But we cannot get away from other types of data, such as we do need to have intercepts, talk to people or do online surveys to get what is called stated preferences. How do people behave, or how do they respond to various things? Other ways are, I heard somebody saying simulators, that you work with simulation. Put people in a simulated environment and observe what they actually do. So I do not want to discount the value of such data gathering techniques. Yet others are the safety culture indicators, whether it is within an organization. If the superintendent who oversees all the drivers is very strict about enforcing, you will never exceed the speed limit is the company's policy, and they have sensors that get data, and there are each of these companies, I shouldn't say each, many of these companies in the United States monitor every driver every trip. It's not that there somebody's looking at them and all the time, but they set thresholds of if the driver exceeds a certain speed or certain acceleration, immediately that is recorded, and at the end of the day or end of the hour or whatever it is, the supervisor sees on a dashboard by driver, by collection of drivers, by location, so on and so forth. So if the supervisor is very strict, saying that you will not exceed the speed limit, and they hold accountable the drivers who exceed the speed limits. I don't know what holding accountable is, maybe reducing the amount of time they work or penalties work. That's going to drive the organizational culture, saying that we must obey the laws this way. Compare it to another organization where they say, oh chalta hai, they're not going to enforce it. That reinforces the behavior, and oh, it's okay, my supervisor. That's the company. But social is within a neighborhood, within our organization, within our peers. If each of us says, I will not be in a vehicle if that is going to move if everybody doesn't wear a seat belt, you're now pressuring others to do that. There was another example. Oh, other gross indicators are, you look at a neighborhood and the prevalence of adverse safety outcomes in terms of crashes that involve pedestrians or vulnerable road users. If it is within the colony or community, let's say the IIT campus here, IIT Guwahati campus, almost all the users are residents here. There may be a few who are vendors or some employees who live outside and come here, but a vast majority of the travel is here. And if we see repeated close misses or repeated crashes that involve vehicles or vulnerable road users, that means the culture here is too lenient and allowing this. Whereas, oh, over the last 2 years or 3 years, this has come down. That means something is changing here, and people around are less tolerant of violations, are less tolerant of people taking safety risks, or less tolerant of people putting others at risk, not just themselves. I gave you an example the other day about credit scores. That gives you broad indications of how people behave. If they behave in one way with their money, they are willing to take. There are studies that have shown that there are close correlations with traffic safety outcomes. Daniel, you had your hand up? Okay, scratching your head. Okay. Yes, Ritesh?
Sir, actually about credit card actually we are talking about.
What was that?
It's a credit card.
What about credit card?
Sir, while using credit card actually our CIBIL score decreases.
It may or it may not. I don't know how it is monitored here. I know in the US, if you use your credit card responsibly, it will go up. And if you apply for a new credit card or new credit, whether it is a loan to buy a bicycle or to buy a motorcycle or whatever it is, there is usually a dip when you take dip in your whatever that score is. But then as you continue to be a responsible user, the score goes up. So these are some of the things that we don't see traditionally. That's what I meant by emerging. Yes, Ritesh?
Yes, sir. As we know that traffic safety should be the proactive approach.
Yeah.
So when we are talking about the near misses and heartbreaking, so can you talk little about the surrogate safety indicator thresholds, like in the heterogeneous condition, and when we will move to the homogeneous situation, like how we can talk about that?
I don't think I'm an expert in the heterogeneous traffic conditions that we see in India. There are many ways to look at it. I will comment on it briefly and then come back later because I want to touch upon it. One big thing is, what is the societal acceptance? Here, when I am driving, or I haven't driven in India in 40 years, okay? And even when I drive outside of campus environments, I'm almost closing my eyes because here I can see people driving and you put your finger out, maybe you'll touch the car next to you, okay? In the US, if you come within 2 meters of the car next to you, so it is not accepted there, whereas the smaller gaps are accepted. I'll give you 2 examples that I have had many of my colleagues who are from the US, born and brought up there, who lived there, no Deshi connection otherwise, no connection to India. One of them has come here many times, one came once. So their observations. One is we went in an auto rickshaw once. His observation was that the auto rickshaw driver thinks that if the front wheel can go in a little space, the whole vehicle will go in that space. Whereas in the US, that is not acceptable behavior, okay? You need to make sure you have enough space and a cushion around you. The other person said that after driving here, lane discipline, heterogeneous, you've got so many vehicles all over the place, and the attitude is let and let live. It's not hit and get hit, okay? People are aggressive, they are willing to take very short gaps, time gaps or space gaps. Whereas that is not the case in the US. Yet other things are, for most urban roads in India, the operating speeds are less than 50 kilometers an hour, maybe even less than 40 kilometers an hour when you have traffic jams. Whereas in the US, even on urban roads, maybe there are a few hours where it is less than 40 miles an hour, which is 60 kilometers an hour. So as speeds increase, if you have an incident, adverse safety, the consequences are much greater. As speeds increase, within the same reaction time of 2 seconds or 2.5 seconds, the distance you travel is much greater. That's why you need more gap, whereas in the Indian condition. So to set the thresholds, it depends on what may be appropriate in a tier 2 city like Guwahati may not be appropriate in Bangalore or Delhi. So you have to set those thresholds accordingly. This is as best as I can answer your question. The other comment that one of my other American colleagues made is, people in India drive, if there is lane marking, there's no lane marking many times, they use the lane. Is there anybody who has not been on an airplane? Okay. They use the lane markings like the airplanes use it as a runway center line. So the vehicles want to straddle the lane marking and go. So what are the different types of families or classes of models? You have regression models, where you have Poisson, a negative binomial regression. logistic regression, especially when you have discrete variables or discrete outcomes. And so that's where binary, whether you're likely to have a crash or no crash. And then there are negative binomial. I've given you an example. It's exponential of some linear or nonlinear. The beta 1 average daily traffic, beta 2 lane width, beta 3 shoulder width. This looks like a linear. It doesn't have to be linear. It depends upon how you envision a variable is. Again, part of it also depends upon, I told you, some variables may have range of values from 0 to a million, others may have 0 to 100. So how you account for it? Just like you may use log scales in certain other things. There are ways to mix and match. Just be aware of it. We don't have time in this course to go into it. I just want you to be aware of that. Base models. So a lot of the crash modification factors and so on are based upon if this then that. These are conditional probabilities that we are using. Okay. So you need to incorporate prior knowledge, or these models incorporate prior knowledge to build in, say, okay, over the years we've had these. So this another strategy, and I just have one of my PhD students is looking at a new way, is using some of the Markov chain tools. That is also a chaining of what has happened before to try to figure out what will happen next. That may be particularly suitable for time series types of analysis when you're looking at large data over a large period of time. When I say large period of time, it could be 365 days where one day is thing, but in our case that's not necessarily the case. We are looking at many years or many months. I think in the feedback that I received from last night, a few of you asked to comment about AI and machine learning techniques. While I'm familiar with them, I'm not an expert in that. I partner with other colleagues who have that expertise. I bring the transportation safety data background. They bring the machine learning, AI, natural language processing type backgrounds. So we work together. So I don't have enough. If you ask me to describe the details, I do not have that expertise. But I'll tell you a couple of the examples that I've got. Is one project that I'm working on has to do with the narrative that is written at the end of challans. I believe I have talked to you about this briefly earlier. So these narratives could be as short as 20 to 30 words to maybe 150 to 200 words. We are a lot more fortunate in the US that all the narratives are written in English. Professor Maurya showed examples where it was written in Hindi or written in Bengali or other languages. So yes, we can use other techniques. It used to be pattern recognition, character recognition tools, but now I think AI models can do it better. But talking about English, it is very hard for an analyst to look at, we have 40,000 crashes a year in Nevada. If you had to even spend 3 or 4 minutes reading the narrative and then explaining it, you're looking at 5 minutes to 10 minutes per thing. So that's 400,000 minutes. It's very, very labor intensive. So maybe you have multiple people, then you have variability across people. So what we are doing is, my colleague's name is Professor Ji Woong Park. He and another postdoctoral researcher and I were working on looking at strings of words. What if we take 2 consecutive words? What if we take 3 consecutive words? What if we take 5 consecutive words? Can we discern things? And some cases it is just by looking 1 or 2 words, they may say alcohol in the narrative. Alcohol, it may be that there were bottles of alcohol that were sealed in the car. It was not that the person was under the influence of alcohol. So you need to read it. So, and what we are trying to figure out is, one, what is the precision that we can have, and he's using so many different models. And how many words do you need to have a reasonable amount of precision? There's a trade-off between the computational power, the time that you need if you're going to look at 8 words every time. So just like we talked about dynamic segmentation this way, you look at word 1 to word 8, then word 2 to word 9, word 3 to word 10. That's very intensive if you want to go to 8 words, whereas if I'm going to look at 4 words at a time, it's computationally less challenging. So, these are some of the things that we are doing, and looking at the use of natural language processing. And other part that we are doing is to try to minimize the time that a police officer needs to spend in writing up either a challan or a crash report. Every minute the police officer is on the road, the police officer herself or himself is at a risk of being hit by other vehicles. Yes, they stand around the vehicles, but there are so many secondary crashes. And every time the police vehicle is there, we have the lights that are, it's a distraction to the other motorists. Not only there are potentials for secondary crashes, but that is a reduction in capacity. People slow down or their behavior changes. So, our goal is to reduce the time that it required to properly document either a challan or a crash report. So, what we are trying to do is, in addition to what has been done in Nevada and other states where we have electronic devices, usually computers or tablets, is have the officer speak and voice recognition. Now, what we have there is a lot more homogeneous, just like traffic is homogeneous there compared to here, but even there is variability. We have different accents. We have where we live in Las Vegas, Nevada, we have a substantial portion of Spanish speaking population from South and Central America. Their diction is different, and they serve in our law enforcement. Then we have immigrants from so many parts of the world there. So, what we are doing is using 10 students who have different backgrounds to speak and trying to train the model to recognize different accents. Then we are giving it to the police officers and say, hey, can you have a mix of your representative mix of your people, and when they speak we also record that. What is the computer saying they said, and then somebody, it's a manually intensive thing, how accurately are we capturing that. So, that's a totally different thing that I am not trained in, but I have the expertise from the safety side to make sure that if it makes sense. So, these are some of the evolving tools and techniques, and I think in the Indian context with IRAD, and especially where you showed the narrative of the challan, just like India went from the landlines where it was very less than 1 or 2% of the population had access to a phone in the mid 1990s to 2010, about 15 years. Better than 50% of the population had a mobile phone, and by 2020 I would say better than 85-90% of the population has not just a mobile phone but a smartphone. So, in capturing the data, you are talking about the challenges. Can we use some of these tools and techniques? Have the person dictate it, and now we can customize it. If it is in Bengal, maybe they are more comfortable speaking in Bengali and capture that in Bengali, and then Google Translate will help you do that. There are lots of other things. I don't own stock in Google, okay, I am not promoting Google, I am just using that as an example. Think about those things to leverage, just like we leapfrog from landline to mobile phone and the UPI payment. Not everybody had a bank account, check, so on and so forth. I think it is possible in the safety domain for the country here, based on each state's variations across states, to adapt and adopt such tools and techniques. Others, we talked about simulation, and digital twins are gaining great amount of momentum, but mostly in looking at the machine, and perhaps the machine to roadway or traffic signal interactions. When it comes to human behavior, it is very hard to clone each one of us and our behaviors. How I behave at 8 a.m. in the morning for a certain stimulus may be very different from how I behave at 6 p.m. when I am on my way home after work. The same stimulus, I might have a different response, and one of my colleagues talked about that in terms of the mental emotional state that we have. So, I think the digital twins are less likely from our operations perspective, but more so from a vehicle design, vehicle use and interaction when we look at the connected automated vehicles and infrastructure systems, that pairing. Daniel asked me about electric vehicles and the infrastructure for electric vehicles. I think that's another domain where we may be able to capture some of these behaviors, more so from an electrical engineering perspective, the charging behaviors and so on. Spatial analysis, I think we've talked quite a bit about this. I talked about it, Professor Maurya showed examples of hotspots, of heat maps, and one thing that I worked on maybe 6-7 years ago when I was at Tennessee. If you look up my publication, we had a few publications that use geographically weighted regression. So you give different weightage, just like we said, different weight for fatal crashes, different weight for major injury, different weight for minor injury, based on geography. Can we have different weightages? Urban rural is a simple example, but it could be by pin code, but it could be by panchayat, it could be by municipality. There are differences across. How do you take that into account? The key there would be, how do you come up with the weight? We can say, hey, we can use different weights. How do you come up with a reasonable way to say this is the weight that you need to give for geography area 1 versus 2 versus 3? So where do we use these? Where do we want to make improvements to the infrastructure, whether it is a hard infrastructure such as a roadway, lane width, shoulder, absence of shoulder, median, edges of pavement, so on, that's one. Traffic control, signals, signs, markings. Targeted interventions are more so from the enforcement side and to some extent education to bring about behavioral changes.
Education or enforcement?
Both. Education, we know certain areas are more risk prone or people exhibit greater risky behavior. I'm not talking about going to your neighborhood, going to your neighborhood, going to your neighborhood and talking about. But I think Professor Maurya was the one who told, you're entering a high risk, a high crash zone. So education, maybe you just put up signs that accident prone zone or crash prone zone. So you're alerting the motorists. Okay. We could have variable message sign that it is only active in certain times. So education just doesn't mean that you interact with a specific geographic group of users or a school or so on.
No, I will elucidate. Can I elucidate a little?
Yeah.
So basically, if you go from Bangalore to Chennai,
Yes.
on that highway, it is barricaded. No cows, no animals, which means no human beings can enter the highway. But many highways are not built like that.
Yes.
And they have been built over what you call rural areas.
Correct.
So they have no idea. For them, I used to cross the road yesterday, so will I cross today also. So here, if human intervention is not arrested, it will lead to more and more of these unintended events.
Yes.
So here, the only thing is enforcement.
Enforcement is the first thing would be education. Work with the village head or the gram panchayat or the gram council to let people know, yes, this is how you used to do it. Now you need to change behavior. Okay. Consequences are great, and unfortunately sometimes people only realize when it hits close to home, maybe too late. Enforcement, but can you have police over the 300 kilometer stretch? Chennai, I think that's about 300 kilometers, right? Chennai to Bangalore or Bangalore to Chennai? Yeah. I know it is barricaded, you said, but think about a parallel one in a rural setting. It's impractical to have police there. It must be self-enforced there. People impressing upon their neighbors, their friends, their relatives saying, no, we shouldn't do that. But then it all becomes a matter of convenience. Hey, I used to cross here. Now if I have to go from here to there, I have to go half a kilometer that way, cross there and half a kilometer this way. That's 1 kilometer extra. And a lot of those people are walking or bicycling or pushing something. That is a tremendous barrier. So from an engineering design perspective, can we provide them an alternative way to cross? Underpasses, bridges, but there are some social behavioral issues. What I understand is in urban areas where you have subways, there are acts of mischief that go on in the subways. So they prefer elevated things where it may be better lit or better exposed. So there are other unintended consequences. I think we have discussed many of these earlier. I just want to recap. thing that I haven't talked specifically is the roadside hazards. Professor Maurya mentioned a little bit of that, the clear zones, safe zones on either side of the roadway. He showed examples of the chevrons, or how much space do you have where before you have the guardrail, or if you have a curve where you have lots of run off the road crashes, how might you provide additional shoulder. Not to have very rigid objects within the clear zone. Unfortunately in India, as I travel on road, I see lots and lots of, I think he had several photos that have these stone markers. They're very dangerous if you look at. And going back centuries ago, the emperors who ruled across India, they did some very nice things, things that with very good intentions. They planted trees on either side. The Grand Trunk Road is an example, to provide shade. But if you look at the trees, they are very, very rigid objects. If a vehicle goes and hits them, all the momentum is going to be absorbed. Energy is going to be absorbed by the vehicle, not the tree. Okay, the trees probably, some may break if it's small, but when you have a 100-year-old tree. So we need to move away from that, and that's a lot of investment we need to make in the clear zones. And in much of the developed worlds or high income countries, we are required to have breakaway signs. The breakaway sign is even a traffic signal that is very heavy mounted, and we may have a cross arm that is about 30 meters long, 90 to 100 feet, 5-6 lanes. They're very, very heavy. But where you're mounting it at the base, you look at it closely, there are 4 bolts. Or if you're looking at a stop sign, speed limit sign, there's if something hits it at more than 10 kilometers an hour, the sign will break. So what happens is the energy is not absorbed by the vehicle that strikes it. It will slow down the vehicle. So when you do that, the occupants of the vehicle are less prone to injuries, or more so the internal body injuries to the internal organs. But what we have in India is counter to this. We have lots of trees. We have lots and lots and lots of these stone or metal rigid things, ostensibly to keep vehicles from going away from the roadway. But even there, you look at the gap spacing between these stone markers that you have marked with black and white. Sometimes, to me, it's my personal observation. Okay, people are doing it because they said, "Oh, we need to put markers, to laga de." He gave a very good example. Oh, we need to put 6 signs, so put them all 10 feet away from each other. Not that you need to put it around the curve. It's just checking, tick mark a box. We need to do this, so we are doing this. But then it is incumbent upon us as engineers, as planners who have a lot more knowledge about this, to tell the layperson who the contractor is employing laborers who don't have an engineering degree as to why and where what it is. That's why detailed drawings are important for the field, and post construction field inspection to make sure what was designed was what was done. So just a quick digression here. Let me look at the time. Yeah, another 15 minutes I should be done. I'm sorry. We have until 5 or 5:30. I'll try to cut it short. A simple example. One of the, when I was at Iowa State University, director of an institute there, we had one center within the institute that was the Concrete Pavement Technology Center, the National Center for Concrete Pavements. And they did a lot in terms of what concrete mix you should have, so on and so forth, and come up with very precise designs. And the director of that used to be the chief engineer of the State Highway Department. At one meeting we were talking about some things, and he said, you know, we can come up with all of this. Who is the one who is placing the concrete on in the field? It is one of the contract workers. That person probably has a high school education or so. They say, oh, this mix is so stiff, so let's pour 2 more buckets of water. It makes it easier to work with, right? Otherwise the concrete is so stiff, it is very hard for them to vibrate or spread it. And that worker's attitude is, I want to make it easy for me to work. So no matter all the science and engineering that went behind to come up with this design that was so perfect, saying this is the water, cement, sand, aggregate mix, it's all gone out the window because the construction worker said it is too hard to work with that mix, dal do thoda aur pani. So think about who it is who's helping you deploy your design, construct your design. How do you inform them? How do you work with them? And let's not be condescending. Help them understand why it is. So next time you don't have to spend so much time. Don't say you do it because I told you to do it. You do it because these are the reasons to do it. So then they will start owning it and thinking about it, owning it. So next time they will take pride. Sir, आपने देखा क्या मैं कैसे किया? They have a lot more pride in doing what they do. Let me go on. Operational factors. One thing that I haven't talked about previously is driveway and median openings. The example you gave from Bangalore to Chennai, where you have barricaded, that's what we call freeways. You can only get on or off at restricted points of access or egress, on ramp and off ramp. But here across India, even on national highways, we see so many points where you may have a frontage road or access road, and then every now and then you will see somebody coming. And you have vehicles that are traveling at 80, 90 kilometers an hour, and all of a sudden you see somebody with a little donkey cart that is coming onto the roadway with a speed, operating speed of 5 kilometers, 10 kilometers an hour. It's hard to avoid that. So how do we educate that or minimize that? In the US, that's a big problem in urban areas, because every business owner wants to have a driveway to enter their parking lot from a high-speed road. Their thing is, if I make it easy for people to come into my parking lot, I'll get more business. I make it more difficult, I'm going to have fewer people. The last point here, human-machine interface, vehicle controls in vehicle systems, is something I want to spend just a few seconds. I talked about this early on yesterday in terms of the more you get to used to certain things, the more you start taking things for granted. That can lead to complacence. That's one. The other thing is, the modern automobile has a command and control center that's more of an infotainment system than just the olden vehicles. Well, you have on the dashboard 2 or 3 dials. That's all. Now you're driving, I want to change the channel of the music, okay, or I want to make a phone call, or on my screen I see SMS, so on and so forth, lots of things. That causes a lot of distraction. The focus is not on driving, it is on what is on the console, what do I need to do. So that is some of the downsides of some of the in-vehicle systems. However, there are lots and lots of positive benefits of these in-vehicle systems. We've talked about the lane keep assist, okay, lane departure warnings, forward collision avoidance systems, rear collision avoidance systems. Even when you're backing up, sometimes if you have somebody going in newer cars, you get a beep or a sign. You have multiple blind spot detection systems in the newer vehicles, that under your side view mirror or on your dashboard you can see a blink or something saying that there's a vehicle in your blind spot. When you're changing lanes, don't do that. Environmental factors, there's very little that we can do to control the environment, but there are a lot of things that we can do to educate the road users about how to handle these things. Maybe better lighting if you have lots of dark, crashes during the night time, or under wet conditions, can you design the roadway better so that you drain the water off the roadway. Work zone, I put that under environmental. We need to educate our road users, and that's a place where more enforcement is easier to do. If they violate the speed limit that is posted in the work zone, give them a hard challan. I say that, it's easy for me to say. Even in Nevada where I live, we cannot have automated enforcement.
Sir, I have a question.
Yes?
Oh, people are violating the rules, then why we can't do speed limitation in like vehicles only? Like we start to make like that maximum speed of is 150 only. Why we are giving 300 kilometer speed limit? If we know that the safe limit is 120 or 130 maximum, we are saying we are going in freeways also. If we are using, we have to use 120, not more than that.
I agree with you wholeheartedly. I think that is something where we need to work with our elected officials, our appointed officials, regulators to come up with this. Most vehicle manufacturers use that as a marketing tool. You can go from 0 to 90 kilometers an hour in 2 seconds, in 3 seconds. Oh, look at this, my vehicle can allow you, it's got so many horsepower, you can drive at 180 kilometers an hour, 200. How often are you able to do that? I wish we manufactured vehicles that did not have the capability to go greater than what you are saying, whether it is 100 kilometers or 150, maybe what you have is 140, 150 kilometers an hour, but speed regulators that will not allow the driver to operate greater than a certain speed based upon the context where they're driving, when they're driving.
I can add one thing over here.
Yes.
I can add one about it. See, basically regulation also plays a lot over here. So in Europe, you have the no horn, low vehicle zones,
Yeah.
Low speed zones.
Yes.
So for example, if you're approaching the hospitals and
healthcare
education centers, not only it is, first of all, you cannot honk, you're immediately fined. And I want to talk about the technology. There is a zone technology. So you know about geofencing, right?
Yes.
So now geofencing has gone to the levels of, you can create.
Can you speak closer to the microphone? Yeah. Yeah.
Hello.
Yeah. Move closer to the microphone.
Yeah. So I was talking about geofencing. Basically now OEMs provide the government all the services to zone your vehicle
Yes.
and then categorize the zones into speed limits. So you're assigned. Okay, so the vehicle knows that it is going into that zone and it simply cannot exceed that limit.
Yeah.
So those technologies are available now. I mean, it's a matter of, again, regulation versus value of life versus cost.
Yes.
So, I mean, we cannot expect everything to happen in all parts of the world, but technology is available.
I agree with you. And tomorrow I will talk about, for a few minutes, about how all of these come together. Okay. I agree with you 100%. There's technology available, but is there a willingness to adopt it?
Sir, I want to say one thing. I've seen a movie.
You haven't
in-
talked the last 2 days and now you are full of chatter. I'm so happy to hear the comments. Thank you.
Sir, I have seen a movie in that Tesla cars were there, and there was a cyber attack for some war, and in that it happens to they hack all the cars and crash started happening. So in that I want to say and a family was there who had a manual car and they are trying to save their lives. So I want to say that there is a technology, I can say that, but if there is, like I said, if there is a limit in, initially we are not going to build a 300 kilometer per hour speed, we have 150 or 120 we will build. There is a chance of we can escape if in future also such type of cyber attacks also happen, if we are looking for like fully automated vehicles in future. So this can be possible, some cyber attack will happen, and how we are going to get saved. So if there is a speed limitation in starting only, we have some time to control it or manually.
Yeah, you have very valid points and I agree with you once again. This is something I alluded to earlier, I can't remember, yesterday or so. Concerns related to vulnerability of our physical infrastructure, that is the traffic control signs, vehicles, from cyber attacks or intrusion or insertion of even a bad package of information as we go to more and more of the CAVIS domain. There was a very nice example. If you ask Professor Google, you can find it. I think it was in the year 2013. Two people said, we are going to hack, get into one type of General Motors car, take control of it. And they showed that they can do it. This was 2013. Today, that is very common, that the threat is there. There was an example, you talked about a Tesla car. Two people had identical models of the Tesla car parked next to each other. Technically, they operate the car with either a mobile phone, Bluetooth technology, or you have a little card. The driver of one car, owner of one car got into the other car, the car started, then they drove away. The other person did the same, and then they realized after a while, this is not my car, because they were looking for something, it was not there. So there are those threats and vulnerabilities. How do we harden it? I don't have an answer. We need to work with cybersecurity experts to do that. And there are people who are looking for the slightest opening to take advantage of things. Let's move on. I believe I have talked about much of this. I want to get into data integration. These are the various types of data we've talked about. The last one, behavioral studies, Dr. Bhardwaj gave 2 examples from the naturalistic driving study that was conducted, Virginia Tech House did, and the 100-car study that was the predecessor. I didn't go into a whole lot of details. But the others, we've talked about it, the repair history, the vehicle registries, the National Vehicle Registry. If you are buying or selling a car there, buying a car, you can look up its history of has it been in a crash, not when did it go for oil change or so. But if it was ever in a crash, collision or repair, you can find that. So what does that have to do with safety? You can look at the condition of a car that somebody may say, oh, it's in pakka condition. But if it doesn't have all the safety features that were in original condition when you bought it from the OEM, may be different. But we can also use it to find out 2 identical vehicles operating in 2 different environments has a much worse maintenance or safety record than others. What is it? That must have to do either with the driver or the environment. So you can tease out inferences by looking at a collection of these data, not necessarily just an individual stream of data. I showed you some examples of how to tie data together from different fields, the unique record numbers. I also said we can use the geography, we can use the date and timestamp, the type of event that took place. There are many ways that we can use to stitch together what might be seemingly disparate data sets. So it's not easy, it's not simple. There are many challenges. How do we overcome the challenges? Technology is a big solution. If we are going to rely on labor, that's going to be much harder. As many of you have talked about, using emerging tools such as AI or ML. The last one of the last ones I have there, missing data. Many of the records do not have complete data. So how can you either fill in information to fill in the gaps, interpolate or extrapolate? Be careful when you're extrapolating. Once again, there are tools and techniques that are available. Or in some cases, you have to just discard certain data that don't make sense, that are extreme outliers, or you cannot justify why it is. The spatial joint deterministic linkages, we have done that. The deterministic linkage is the one what I showed you yesterday and today. Probabilistic is based upon more so when you do not have this discrete or definite fields, where you have more descriptive text entry. What is the probability that these are, or likelihood that, hey, you had a crash, somebody was injured, they were taken to a hospital, you have 2 different records. This crash occurred at such and such a time, it must have taken such and such a time to go there. The likelihood is it's the same case. I will not dwell more on this, just be aware that you need to work with people who are database experts if you go beyond a certain level, in terms of trying to tie data together. So the comment I have to my colleagues here, as they are developing and deploying the IRAD things, be mindful of not only what data you're capturing, how are you going to store it in what databases, and how would you link not only what you get from IRAD, but with the motor vehicle registration, with the driver's licenses, insurance, so on and so forth. Okay, I'm going to stop here. It is 5:15. I have 3 or 4 more slides, but I will pick this up early tomorrow. I'll just show you. And these are case studies for implementation. I apologize that I'm not able to finish it, but I want to be mindful. And these are 3-4 slides. I will finish them tomorrow. Any questions, comments, concerns? Please speak up. Online people also, I'm open to questions. Let me get back to you in just a second.
Sir, as I am working on the policy part of the road safety management, sir. Sir, I have question about fatigue driving, sir.
About what driving?
Fatigue driving.
Fatigue driving, okay.
Sir, how can we get data related to fatigue driving as we have no clear law for it, sir?
I don't know, Rahul. I don't have an answer. Rahul, right? Rahul,
Yes,
no?
sir, yes.
I don't have an answer. I'm going to point you to my colleagues here.
Yes.
But as there are lots of tools, as I said, I'll show you tomorrow some examples of how companies are using technology to figure out if somebody is driving fatigue, driving
Yes.
drunk, using mobile phone,
Yes.
so on. I can tell you that how it is done in the US context.
Yes.
I do not have an answer for you in the Indian context.
Okay, sir. Thank you, sir.
You're welcome. Anybody online have any questions or comments? If not, let's, yeah. Did somebody say anything online? No. Okay. If not, we will reconvene at 9:15 a.m. tomorrow. Professor Maurya, Dr. Bharadwaj, 9:15, right? And so we will do that at 9:15, and then later part of the morning, I will work to try to tie together. It's called a tutorial session, but it may be more or less a discussion on how we tie the bits and pieces that we have talked about over this last 4 days together. Thank you all very much.